Hello, I will be going through the updated parameters that will be seeing released with the 21st of May results for the Merino, Dohne and SAMM evaluations. When we have a look at the type of information that is underpinning our analysis, we've seen that over the last couple of years, we've seen an increase in the amount of data and flocks submitting to the sheep genetics analysis. With this, our data has changed over time. So up on the slide here, I have the example of rear type and birth type. Over the years, you can see that the amount of information we're getting with our multiple birth animals, so being twins or triplets, has increased. Previously, we were seeing a lot more information with just our single-born, single-reared animals, whereas in the last 5 years in particular, we do have more information from our multiple-borns, and this type of information is now being better reflected within the analysis with these parameter updates. In this video, we are going to go through the 5 different updates that are being made to the MERINOSELECT analysis that underpins the evaluation. These include genetic parameters, standard means for traits, the pre-adjustments that are being made within the analysis, the partitioning of genomic versus pedigree information, and standard weights for carcass traits. The first that we're going to look at are genetic parameters. This includes our heritability and variances within the analysis. Within the analysis, we have what we call variation for each of our traits, as well as a heritability value. A body of work was undertaken to review and have a look using the most current data and all of the information we have available to us now to see that if what we were using as our estimates for variation and heritability for each of the traits is still reasonable. From this body of work, it was seen that historically well-recorded traits, there has been minimal change. However, for traits that we've seen a large uptake in the amount of information in recent years, including adult weight traits, post-weaning fleece traits, and some of our visual traits, what we were currently using the evaluation is no longer relevant, and we do need to update these to better suit the data we have available. The example that I have here is adult weight. So in the older analysis, we were using a variation of 40. However, with the body of work, it's seen that the new variation is 17.5. This is a change of 22.5. This is quite a large difference, and so within the new analysis enhancements being released on the 21st of May, we will be using this updated information to underpin and calculate our ASBVs. In addition, we're going to have a look at what the heritability is for adult weight. Currently, within the analysis, we were using a heritability of 0.4. However, through this body of work, the new proposed heritability that is more relevant is 0.54, which is a change of 0.14. This is similar to some of those other traits that I mentioned that we've seen a lot of data increase, and so we are expecting ASBVs to have some movement around them for this. Another part of the genetic parameters that's being updated is the correlation. So as part of this larger body of work, all of the correlations used within the MERINOSELECT analysis were reanalyzed and compared. Generally, there was good agreement between what was previously used and what we're now proposing will be used for a lot of our variation. We are going to see some updated correlations with our post-weaning traits, our adult traits, and our visual traits, as we have more data for those within the analysis to better inform this correlation and give us a more accurate reading. Next, we're going to look at is our standard means for traits. As part of this larger body of work, the standard mean used within the evaluation to underpin the calculation of ASBVs was reviewed for all of our traits. Most of our larger changes between the old and the new occurred where historically the data set has been small, so we just didn't have this information available the last time our parameters were recalculated. And this is reflecting the population change within the analysis, and is also aimed to reflect the amount of data we're going to have growing and into the future. An example I have here is adult weight again, just to give us an idea of the type of changes that we're going to be seeing. So currently in the analysis, we have a standard trait mean of 44 kilos for adult weight. The data that we have available to us now shows that it's actually 59.3. And in recent drops, it's even higher with 61.9. Using this as a basis, moving forward, we are proposing a new mean of 60 kilos for adult weight within the analysis. What standard trait means allow us to do within the analysis is to account for different environmental or management impacts across flocks. A really good example of this is, for example, fleece weight. So if we take the example of adult fleece weight, some shearing times may be shorter or longer than others. We could have 6 months worth of wool growth, 8 months worth of wool growth, or 12 months worth of wool growth across the analyses. By comparing it to a standard mean, we're able to remove some of that environmental impact and be able to calculate ASBVs more accurately. So improving our standard means to the more current and useful data set is a good thing. Next, we're going to have a look at our pre-adjustments within the Merino Select analysis. So pre-adjustments could also be called fixed effects, and it's allowing us to remove some of that environmental impact that we know has an effect on how an animal performs. These include things such as birth type, rear type, age, and dam age. When the larger body of work was conducted with our parameters, it was seen that previously what we were adjusting for with birth type is generally quite close to what the new data set is suggesting. So there'll be very little change within the birth type adjustment. For the rear type, we did see that it was a little bit bigger than what we were currently adjusting for, which, if you remember back to the first slide where we saw more information coming through on our twins and our triplets, makes sense. Age was generally having a stronger impact than originally was being calculated for within the analysis, so we're going to see some changes with how we adjust for age for different traits within our analysis as well. And additionally, dam age was similar but a little bit stronger than what we were currently using, so some changes will be occurring with that one as well. For example, what this is going to look like on our impacts for some of our breeding values is I've listed a couple of traits here that we've seen some additional or some stronger adjustments being made for. If we use the example of curvature, we've now got a birth type and age adjustments being added with the calculation of that trait. Similar for staple length, staple strength, and work, we now have a small age adjustment that previously wasn't being included within the analysis. If we use an example, so for this example, I'm going to look at post-weaning greasy fleece weight. Currently within our analysis, the growth per day adjustment based on age that we were using was 0.006 kilos per day. With the body of work that's been done to reevaluate the data within the analysis and have a look at the impact of age, we can now see that it's more closer to 0.021 additional growth per day. So we'll now be including that age stage adjustment within our analysis to calculate post-weaning greasy fleece weight. Next, we're going to be having a look at how genomic versus pedigree information is used within the analysis and some of the partitioning changes that will be included with these analysis enhancements. Within the analysis, when we have a genomic test available to us, currently we've been attributing it at about a 0.5 weighting compared to pedigree information. This is known as lambda and is indicated by the purple line on the graph here. As part of this larger body of work looking at the parameters that underpin the Merino Select evaluation, the amount of information being contributed to ASBVs from genomic tests or that genomic information for the 5 major growth production groups, including carcass, weight, wool, visual, and wax, were recalculated. As you can see from this slide on the board, the amount of genomic information that can contribute to an ASBV is higher than what the 0.5 was allowing it. So with these new analysis enhancements, the proposed improved value of 0.75 from genomic information is going to be used. As you can see, this is a better representation of the amount of information we have available due to this increase in genomic information uptake we've seen in merinos in particularly the last 5 years. So the information we'll be getting from a genomics test within the analysis is better going to reflect the information that we have available to the database and using it more effectively. Finally, we're going to have a look at standard weights for carcass traits. So within the analysis, we adjust our carcass traits back to a standard weight depending on their age stage. The current age stages of weaning, yearling, hogget, and then a carcass measurement, as well as what the current data is showing with the mean column on the slide, as well as the proposed can be seen here. So to have a look a little bit further into what this means is, for example, a weaning carcass age stage. For eye muscle depth and fat, we were currently adjusting to a standard weight of 35 kilos. With the body of work that's been done, the data showed that the mean is 36, and this wasn't too far off what we were previously using, so we're proposing to keep that the same as it was before. However, if we have a look, for example, at our hog at age stage, we were adjusting back to a standard weight of 70 kilos. With the work that's been done, we can see that the mean is actually 55 kilos, so we were over estimating the standard weight. Within the analysis enhancements, we're going to be adjusting it back to a 55 kilo. This is a better reflection of what we're actually measuring and what we're capturing on farm and how we can use it to inform our ASBVs. So just to summarize the different adjustments that are going to be made to the Merino Select analysis with the 21st of May run, these include updates to genetic parameters, standard means for traits, pre-adjustment factors or fixed effects and how they apply to different traits, the partitioning of genomic and pedigree information, as well as updating the standard weights for carcass traits to be more relevant to the age stages. What this is going to look like and its influence on ASBVs. There will be changes and there will be movement to individual animals as well as flock averages. These are more likely to occur in lower accuracy breeding values. The animals that have a good or a high accuracy, we're not going to see as much movement. The high performing animals are still going to be the high performing animals. There'll be a little bit of re-ranking in the middle. As well as our higher averaging flocks are still going to be our higher averaging flocks with some re-ranking in the middle. We did have a look at the correlations between the 2021 and 2022 drops for so the current analysis compared to the analysis enhancements, and there was a correlation of 0.98. So it is still a very high correlation, and any of our movements will be seen in those traits that hadn't been recorded as much beforehand and our lower accuracy animals as well. If we have a look at what this means for individual traits of interest, we can see here that there will be some movement for some of these traits. I just want to highlight it here that, for example, this yielding fat trait, we can see here that the orange line being the new proposed analysis enhancements compared to the blue line, which is the old analysis, it has been a drop in the yielding fat on average. This can be due to those adjustment factors that we saw with that standard weight for our carcass traits.